So, okay. So let's take a look at this particular limit. The limit as x approaches so we'll do infinity. One minus cosine x over x squared. So take a minute, graph that one on your calculator, and see if you can use the trace, figure out what you think it should be, and then we'll go back and review our sandwiches, see if we can confirm what we're seeing. You might have to play around with the window a little bit to be able to see it really well, but -5 to 5 both ways works pretty good. Okay. I don't know if this is any clearer for you, but I actually did the y min and max are just -1 to 1 because it doesn't get very high. And then I did -50 to 50 in the x. And it looks like that. So it's kind of like it almost looks like a bouncy ball kind of a thing, or it gets smaller and smaller and smaller as it goes out. So in any event, what do you suppose the limit as x goes to infinity is for this? What is it getting closer to? What do you notice about the value of y as we continue to go out? It is getting smaller. Those little hills are getting smaller and smaller, so it's leveling off to what? What value of y? 0. Yeah.
Yeah, that's
huh?
not the same graph.
No? Oh, I did O over x. Should be x squared, right? Yeah. That could be a problem. Let's try that instead. So that looks different. Okay, hold on. Okay.
It looked better than ours.
It was more interesting, right? Maybe? I don't know. Ah, okay. So something maybe more like that. Just a little hill in the middle. And then, okay, the limit's still the same though, right? What's it leveling off to though as we go out to infinity? 0. Okay, all right. That's the important thing. So it's supposed to be 0. Okay. So how can we use a sandwich theorem for this one?
Is it 1 minus cosine x sine x?
No. 1 minus cosine squared is sine x. So what I'm going to do first is I'm going to break this into two separate limits, which I can do because this x squared I can distribute. So it looks like that. And you know what? Yeah, I don't think I even need a sandwich theorem for this one. I'm not going to do that. I'm just going to do it straight ahead because I can do that. Okay, so First one. Now, this gets a little different than how we used these limit properties last time because you can't always just plug in. But think about it logically, though. If I, in this first limit right here, if I let x keep getting larger and larger and larger, what is the value of this entire thing getting closer and closer to? 0. So that first limit I can actually evaluate. I know it's 0. Okay? And so then I'm still left with this limit as x approaches infinity of cosine x over x squared. Okay? But that's pretty familiar, right? It looks a lot like this one we talked about over here. What's the only difference with it? It's x squared instead of x. Is there any way I could kind of break this thing up so that I could use that somehow? No, it's not impossible. No, we can do it. I can use that product rule, right? I can make it into a multiplication problem of two limits. And one of those two limits is that limit that I already know. So this is going to become 0 minus limit as x goes to infinity of cosine x over x multiplied by the limit as x goes to infinity of 1 over x. Okay, so do you guys all see how I did that? Cosine x over x squared is the same thing as cosine x over x times 1 over x. And I did that because now I've got this limit that I told you should be 0, that we're memorizing. And I have this limit, which I also know, right? Think about it logically. As x goes to infinity of 1 over x, what should the whole thing be going to? 0. And what did I say this one had to be? 0. So I'm going to get 0 minus 0 times 0. And 0 minus 0 times 0 is what? It's equal to 0, like we saw on the graph. Okay. So, yeah, no sandwiches needed on that one. I misspoke. Okay. So, we were able to do this one by hand. We can do some other ones by hand without using our calculator to assist us here. Now this one's going to seem probably more complicated than it is. But let's say I have that function and I would like to know what is the limit of y as x approaches infinity and what is the limit of y as x approaches negative infinity. Now this one we can do just with some visual inspection. We don't have to go through all of these limit properties, break it up, try to figure out what each little piece is and put it all together. We can just kind of go one piece at a time here, okay? Now technically we are using limit properties to do this, but I just want to have you guys notice a few things in here, okay? So if I were to do the limit as x goes to infinity of 3, what is that? 3, right? Remember, that's just a constant function. It would stay 3. Okay, so that's going to stay 3. What about 2x squared over x squared plus 2? What's the limit as x goes to infinity of just this piece right here? Think back to pre-calc when we did horizontal asymptotes, when we had fractions. If the degree on top was the same as the degree on the bottom, what was the answer? Not 0. The coefficients, right? Remember, as x goes to infinity, this little plus 2 right here has basically no effect at all because it's a super huge number plus 2. Who cares? So the limit is really ignoring the 2. What do you get when you simplify that fraction? 2. Yeah, 2 over 1, 2, right? So the limit as x goes to infinity of this fraction then, 2. It's just 2. So remember, when the degrees are the same, you just divide, and it's the coefficient that's left over. So 3 plus 2, okay, continuing. Then it's 0. Right, just like when we were looking at, like over here, this 1 over x, that's exactly that case, right? We had a degree on the bottom larger than the degree on the top, so that came out to 0. That particular part of that one came out to 0. And I think we did 1 over x squared earlier, also came out to 0, because the degree on the bottom was larger. It's only when the degree is the same that you do this little trick where you divide and take the coefficient. But yeah. Then there is no asymptote. So the limit would not, actually the limit would go to infinity, technically, with these then. But we're not going to look at that stuff with this. Okay, so continuing on, that idea in mind, what's the limit of 1 over x as x goes to infinity? 0. Okay. And then the limit as x goes to infinity of 1? Still just 1. So I can kind of go piece by piece. I'm using my limit properties doing this, technically. But I can just go piece by piece. And now 3 plus 2 times 0 plus 1. 5. So that one's 5. Now if I do negative infinity, it's not a whole lot different. So again, a constant function. Instead of going to the right, I'm going to the left. What is it? It stays 3. So what's the limit as x goes to negative infinity? 3, right? Stays 3. So that's still 3. This one, as x goes to negative infinity, okay, I'm squaring. Whether x is positive or negative, does it make a difference? No. So it should still be the same, right? That should still be 2. Okay? 1 over x. Think about the graph of 1 over x. As I go to negative infinity, what am I getting closer to? Still 0, right? That one doesn't change. And 1. Still 1, right? It's just a constant. So these actually came out to exactly the same thing. They're both 5. So this particular function, what are its horizontal asymptotes? Y equals 5. And that's it, right? It's just got the 1. Because those both came out to be the same thing. All right. So I think we're good with that. Last thing I want to talk about, I actually forgot to put this on the board, but we need to talk about end behavior models, and then we will be done.